All right, we're going to continue with those ideas of augmented matrices and trying to use Gaussian elimination, but we're going to step it up here to 3 by 3 matrix. So let's take a look at this. All the same principles apply. So if you remember from our last lesson, what we saw is that you can switch any two rows. You can multiply through a row permanently, or 3, you could multiply a row and add to another. Now that multiplication of a row is a temporary step. We're not going to permanently change the row we multiply. We're just using that as a tool to add it to another. So again, this is all based in just the elimination approach that we did when we first solved systems of equations, and it is exactly the same idea. There's really nothing we're doing differently here. It just looks different because we're in a matrix, but these operations are the same idea. Okay, so what we're going to do here, we have that 1 in our first row. So remember, we're trying to make that diagonal of 1s, and then everything else is going to be a 0. Now, it's a 3 by 3 over here on the left, so we're going to have a lot more zeros, and we're going to have 3 diagonal 1s, but the concept's the same. So I have that 1 in the top. Now remember how we did that. If you have that 1, it's a very powerful tool. You could then multiply that row by anything, and then add it to another to create all zeros. So here's what I mean. If you take a -2 through that top row, so if you take a -2 through that top row, you're going to create -2, 6, -8, -6. So -2 through that top row. Now you have to run that through all of it. Some people will forget and not touch the augmented side. That -2 is going to affect that entire row. So this is what we would create, and now we're going to add it to the middle. -2 and 2 is 0. 6 and -5 is 1. -8 and 6 is -2. And I've got, did I mess that up? No, -6 and 6 makes the 0. Okay, so same concepts we did before. Now if I was looking at this matrix, what I want to do now is I want to make this entire column, I've got the 1 there, I want to make this last spot a 0 as well. So I'm going to use the power of this 1 to make these other two zeros. So what I would do now is I would multiply the top row by 3, because that will create a 3 and a -3 that I can add together to make those drop out. So that's what they did. Multiply the top row by a 3, add it to row 3. And here's what I've got. Now look what we've got here. I'm looking to try to make this diagonal of 1s, and I already have another 1 sitting there. So what I'm going to do here is I'm going to use this 1 to get rid of these other two. Now the book is going to, well, let me show you. They're going to make it so if you add a 6 through here, look how it's going to create that 0 on the bottom. Now they're going to create just one more 1. I would get rid of this right here first. What I would do next is do 3 times row 2 plus row 1. I want to get this down to nothing but 1s and 0s. I think it's better. Theirs is a little faster, but I like mine better. So we'd run this through there as well and edit that row. Now, but what they did is they wanted to create a 1 in this bottom right corner. Well, we can easily do that. If I just multiply here through by a 1/4, that would create a 1. Now, sometimes you get some pretty ugly fractions. So 1/4 times the 15. Yeah, they're wrong here. This is incorrect. It should have been 1/4. I'm not sure what they're doing there. Should have been 1/4, but okay, but same ideas. Now, let's show, I would have gone further, and I think this last row is wrong. But so what they're doing at this point is they're saying, okay, well, I have a system of equations where I know z equals 21 over 2, y minus 2z equals -6. Do you see what they're doing? It's just a system, x minus 3y plus 4, z equals 3. So if you know z, you could put that into here, you would then know y. If you know z and y, you could put it in and then solve for x. So there's nothing wrong with what they're doing. But if you keep going and you get it all the way down to the 1s and 0s, you have all the answers. Again, I prefer that method. Okay. So I'm going to augment this. Now be careful, this second row is off a little bit. Okay, so here's my augmented matrix. Okay, now I'm going to take you through this. I think I'm going to take you all the way through this one, and they're time consuming, especially when you've got a 3 by 3. In the next couple slides, we're going to learn how to do this on our calculator, and it's going to be hard that you're never going to want to go back to doing it by hand, but let's talk through one more by hand. I mean, when I do a test, I can't really distinguish whether someone has done it by hand or their calculator. Well, that's not true. Sometimes what I would do is say, you have to show me all the steps to work through. So I would do on a test a little bit of each. I may have one or two, maybe a 2 by 2 you had to do all the steps, and maybe one 3 by 3 where you had to do all the steps, and then you'd be able to use your calculator. But let's talk this through. At least we'll do part of it. You see, I've got my 1 in this top corner. So I'm going to add row 1 to row 2. So my next goal is to make this column filled with zeros. So if I add these together, I'm going to get 0, 1, 3, 5. Okay, so I've got ones, I got a 0 here. I'm going to make this last one 0 as well. Now when you have that 1, it's a real powerful tool. So I'm going to use -2 times row 1 plus row 3. Now I'm going to write it below here. If I run a -2 through here, I'm going to get -2, 4, -6, -18. So here's my new matrix. Got 1, -2, 3, 9. Okay. Now it's really easy to make a mistake, and I'm more than capable of making one myself here, but I think I'm good so far. So I have my 1s and 0s. Look what I have and I want a 1 in the diagonal here. I already have one. So what I would do next is I would do, I don't even have to multiply row 2 by anything. I'm just going to add row 2 to row 3. And so that's going to create Okay, so I'm going to just go ahead and do it. So if I add the zeros, I get 0. I add 1 and -1, I get 0. 3 and -1, I get 2. 5 and -1, I get 4. Okay, so I'm almost there. My next step here would be to run a 1/2 through row 3. So that would just change this to a 1, and then I've got my diagonals. So 1, -2, 3, 9, 0, 1, 3, 5. Okay, I wasn't going to finish it, but I think I should. So I'm going to go ahead and, if I can do this without running out of room, what I'm going to do here is I'm going to run, so use the power of this 1 to empty out this row, so, or this column. So I'm going to do -2 times row 2 and add it to row 1. So let me just multiply it through, so that would still be 0. That's going to, oh, no, +2, sorry. +2 through there. 2, 6, 10. Okay, so that's still going to give me a 1. That's going to make a 0. That's going to make a 9, 19. Okay, so I've got all 1s diagonally. I've got 0s everywhere. I would just need to clean out this last row. So I'm going to do -3 times row 3 plus row 2. See if I can do this without running out of room. Oh, shoot, I'm supposed to be adding that to row 2. So if I run a -3 here, it's going to get 0. It's going to keep that 1. It's going to create a 0. -3 times -2, -6, -1. Okay, I've got everything I need. So here's what I know. Z is going to be 2. Y is going to be -1. Now, so I could finish this, and if I were doing it by hand, I would. I'm going to do -9 times row 3 and add it to row 1, and I'd be finished. -9, so I'm going to get 0, 0, 0. -9 would be -18. I'm going to get 1. Okay, I was getting a little cramped for space, but I think I did all that right. So I got x is 1, y is -1, and z is 2. Okay, even if I made a mistake there, hopefully, I don't think I did, but hopefully you follow the idea. So we're making a 1 in that top left space, then we make zeros below it. Then move to this second one. We want that second one, get that 1, zeros in that column. Then get that third one, zeros above it, and you've got the solution to the system. Okay, so no, we're not ready for the calculator just yet. So here's just another one. I'm not going to talk through it. They got a 1 here. Well, I'll do it quickly, I guess. They got the 1 here, so a -2 would be where I would go next. A -2 through this row, and then add it to row 2. Then look how they're trying to get another 0 here. So -3 times row 1. They're using that 1, adding it to row 3. Okay, so next they want to turn this into a 1. You would do that. Oh, you could, yeah, I didn't think about that. So they've interchanged row 2 and 3 in order to make that happen. That was clever. So now they've got their 1. So a -5 times row 2 will help us get rid of row 3. Now, this is a weird one. I've got everything but this last one here, -1/57th. Why negative? Yeah, that's not right. This should be just 1/57th to create the 1. I think they're off there. Okay, now I'm assuming the rest of their answer is right. But anyway, they've created their system. They've written it like this. I would have kept going to finish the rest of the zeros, but you can do this. If you know z is 1, you could plug it into there. You could find y. If you know y and z, you could plug them into there and get x. And there's your solution. Okay, so let's see one where some weird things are going to happen. Look at the augmented matrix here. Is going to be a little complicated. We're going to have a 0 in the second row and then a 0 for the x in the third. So just see how this is made. We got to watch out for some zeros. Okay, so anyway, let's jump to it here. All the same steps, but we get down to 0 equals 0, which we've learned means that this is infinite solutions. All the variables have dropped out, and we're looking at 0 equals 0, which tells the truth, so infinite solutions. They show how to write these as a dependent system on the other variables. I have never asked that of my students, so I'm going to skip that. It'd be a calculus kind of thing, and even then I'm not sure it's all that important. Okay. I'm going to augment this, and I don't think I should have just brought up the answer key from... Yeah, I don't think I want to go through another one of these. So the textbook has the answers to the triads if you want to pull that up, but I've got my 1 here, so then I would take, the first step would be -2 times row 1 plus row 2. That would get rid of the 2 there, and then I could do -1 times row 1 plus row 3. So same process there. Sorry, I'm not going to write the solution to this. You could actually also do this on the calculator, but let's keep going. Let's show you how to do it on the calculator. So in the previous video, I talked about how you can just go into above x inverse is the word matrix. So you got to hit second to get up there. When you first come on that screen, you've got 3 choices. You've got edit, you've got name, then math, and then edit. So you go over to edit where you can enter your matrices. Well, now because it's augmented, we're going to enter a 3x4. Remember, it's rows and columns. So we're going to enter a 3x4 matrix where we're going to put the augmented right in here. So look how they've done this. They augmented it, but they're putting that right into matrix A. Now I'm going to show you an even better trick than what they've done. If you go into the math setting, so quit out of there, go back into the matrix, go over to math, and one of the choices is row reduced. Let me make sure. I think it's RREF. Yeah, it's going to be a different number. Yeah. So it's RREF. Reduced row echelon, I thought is what it stands for, but what it means is it's going to do the entire Gauss elimination process for you until you get down to that perfect matrix. So when you see how hard it was before and how easy this is, of course you're going to want to just use your calculator. But again, if I were testing you, I would ask you to do a couple by hand. But so you put this in your calculator. Now this command is getting it down to the systems they've been doing, but mine will get you all the way down to the solutions. So you don't even have to do the system. Okay, now a quick word here. So on the calculator, I think we've already left this idea. Usually well, not usually. If there is one of the two forms, infinite solutions or no solutions, you're going to see it in that last row. So if I got something like this, where the last row was nothing but zeros on the left, and it had a solution on the right, what this means is 0 equals 5, which would be no solution. If that last row tells the truth, how would it do it? Hold on, no, it would do this. Sorry, I had to think that through a little bit. It would do this. That last row is saying 0 equals 0. There's nothing but zeros over there equals 0. That's going to be infinite solutions. So we've already seen what these mean. It just means the system never intersects or intersects right on top of each other for infinite solutions. But that's what it would look like on a calculator. The last row is going to equal something that going to equal a number. Well, that's not true. The last row is going to equal 0. Well, 0 equals 0. That is true. Infinite solutions. Okay, we're going to finish up here by making some applications. So we've got two investments, an X and a Y. X is going to be the 10.5% investment, and Y is going to be the 12%. So this is like my little dictionary telling me what we're doing up here. There's an X and a Y. Okay, well, this is just good old school. Let's make a system of equations. One of the equations is going to be easy. If you add the two amounts of money that you have, so it should be amount, I should put on here. So you've got some money in that 10.5%. You've got some money in the 12%. Well, if you add them up, that makes the $12,000 you have. Now, let's do this portion would be the interest that you've made. Do you see that? If you multiply, this is 10.5% times the amount of money you have in there, 12% times the money you have in here. Here's how much you make in interest. So I've got a good old formula where I've got this money adds up to my total. This column, this row, is the interest row. I've got 10.5% times the money, 12% times the money. That's how much interest I made. Now, we could solve this with a system of equations, just like we've always been doing. But what their point is here is we could turn this into an augmented matrix and solve it just the way that we've been doing previously. They didn't take this all the way down. Yeah, I don't like this. I would have stayed consistent with what we'd done. But what they should have got if they took it all the way down is that this last row would be 5,000. And then anyway, they could have taken it all the way down, and yeah, here's what they should have gotten. Yeah, that would be the finished product. If we did it on your calculator, if you just took it all the way down, you would get this, where X is 7,000, Y is 5,000. Remember, X was the money at 10.5%, and Y was the money invested at 12. Okay, so they've got 3 here. So the same kind of application. We've got $10,000 in 3 accounts. So we're going to have the 3 accounts added up are worth $10,000. Now here's the interest in each of those different accounts. 5% times the first account, 8% times the second, 9% in the third. So this is the interest you're making off each of the accounts. Here's the total amount of interest. So now, but we have 3 I don't knows, so we need 3 equations. There has to be one equation for each I don't know, but they're saying the amount invested at 9% was twice what was invested at 5. So the amount, so 9% is the Z. I should have done my dictionary, but the amount at 9% is twice the amount invested at 5. So I have this equation. But let's get this in this similar form. So they turned it into this. So we have an augmented over here. We've got a 0. We've got everything else in the proper spots. So augment this matrix. And again, at this point, a question like this, I would be totally fine with you using your calculator. but they've reduced it down. Yeah, they didn't. We're just going to jump ahead. If we did reduced row echelon form, RREF, and then typed in this matrix that you just did, so on your calculator, RREF matrix A, on that front screen, hit enter, you'd get this. That's what you would get, and it would tell you the amount. So X was the 5% amount, Y was the 8% amount, and Z was the 9% amount. Okay, so let's see. So we're going to say X is the 7% amount, Y is the 8% amount, and Z is the 10% amount. Now pause this if you want to try it on your own. I'm going to go ahead and set it up for you though if you're ready. So there's my first one. I've got money in each of these accounts, so I just add them up. Okay, so now let's do the interest part. 7% times that money is the interest there. 8% times the interest there. That's a 0.1 times the Z. And how much money did they make? Oh, these are loans, whatever they are. But okay, so 130,500. Okay. We need one more equation. Where is it? Okay, the amount borrowed at 10%, Z, was 4 times the amount borrowed at 7%. So Z equals 4x. So I'm going to swing this over here to create this equation so it fits our format. Okay, so I would just augment this matrix. Alright, so there's my matrix. And I would just do, especially on a word problem, I would just do reduce row echelon form, matrix A, and I'd get the solutions here. Let me see if I can find these answers for you real quick here. Hold on. Okay, I just took these out of the triads at the back. But if you did this on the calculator, it should be real easy. What you're going to get is X is 150,000, Y is 750,000, and Z is 600,000. All right, so we're just taking those ideas of Gaussian elimination and extending them, and then showing how to do it on the calculator makes it super easy. So again, I would ask you, again, if I'm testing you, I'd ask you to do a couple, maybe easier ones by hand, maybe 1 3 by 3, and then the rest that you could do on your calculator.